So for this problem, we have 3.0 moles of hydrogen and 3.0 moles of fluorine gas are mixed in a 3.0 liter flask. The Kc is 115 at 25 degrees Celsius, and we need to calculate the equilibrium concentration of each component. And here we have H2 gas plus F2 gas in equilibrium with 2HF. So here we need to calculate our initial concentrations of each component. So our initial concentration of H2 is going to equal the concentration of F2, and it's going to be 3.0 moles divided by 3.0 liters, or 1.0 molar. For our concentration of HF, initially there isn't any present, so that concentration is going to be 0. So this is going to enable us to use our ice table, and we can add the concentrations 1.0 for each of the gases on the left and 0 for the HF. Since there is no gas over here on the right, that means the equilibrium must shift over to the right. So there's going to be plus 2x for the change in the moles of HF, minus x and minus x for the change in concentration of the fluorine and the hydrogen. So that means at equilibrium, we have 1.0 minus x for the hydrogen gas concentration, 1.0 minus x for the fluorine gas concentration, and 2x for our concentration of HF. So if we set up our Kc expression, it's going to be the concentration of HF, that quantity squared, divided by the concentration of H2 times the concentration of F2. And that is going to equal 2x, that quantity squared, divided by 1.0 minus x times 1.0 minus x. We can write this as 2x squared divided by 1.0 minus x, that quantity squared. That's going to equal 115. Now, we did a previous example where we had to use the quadratic equation, and it's possible that we have to use it here, but we can take a little shortcut here. If we take the square root of both sides of this equation right here, the square root will get rid of our exponent right here, and that's going to allow us to simplify this down into 2x divided by 1.0 minus x is going to equal the square root of 115. So this will simplify things down for us quite a bit, because we're going to have 2x going to equal the square root of 115 times 1 minus x, or 2x is going to equal the square root of 115 times x, or sorry, minus 115 times x, times, or plus the square root of 115. So if we put everything over on the same side of the equation, we can say that 2x minus the square root of 115, or sorry, 2x plus the square root of 115x is going to equal the square root of 115. And we can much easily solve this when we add these together on our calculator, and we find that x is going to equal 0.968. And this is going to be a concentration, so it's going to be in units of molar. So now we need to figure out the equilibrium concentrations, and our equilibrium concentrations of each of these species, our concentration of H2 is going to be 1.0 minus x, so that's going to equal 1.0 minus 0.968, so that's going to equal 0.032 molar. The concentration of F2 is also going to equal that, because these equilibrium concentrations are going to be the same. The concentration of HF at equilibrium is going to be 2x, which is going to be 2 times 0.968. So our concentration of HF is going to end up being 1.9 molar. So again, we first calculate the initial concentration of all the species present, balance the chemical equation, set up an ice table, put the equilibrium concentrations into the K expression, do a little algebra, solve for x, then take that value of x and put it back into the equilibrium expression to figure out what the equilibrium concentrations are of all the species present.